Uh, so now, when the organizing team has contacted me that you have to give presentation, generally we give the presentation on some technical aspects. So initially I thought what to speak on this particular topic, because it is better that I can speak on some technical field related to control engineering. But then I realized that because to reach to that point or to reach to do that particular research, some basics are required. And if you work in that particular domain, so it is better then it is possible that we can go with the very good research in this particular direction. So as the topic is research oriented thinking foundation of scientific research, and course is on research oriented technical writing. So now we connect both of them. So first of all, the question has come to us: how to write a research paper? Then, then before writing the research paper, one question has come to our mind: why we write a research paper? But that question has come to everyone, particularly in academics. If that question comes to the scholar and even a faculty member also. So if you talk to any scholar, and if he asks why we were writing the research paper, there are different answers, but one of the answer the student can give, okay, that research scholar can give. A paper is compulsory to get a PhD degree. That means, am I audible properly, Dr. Arvind?
Yes, sir, you are
Hello?
audible.
Yeah,
Yes, sir,
yeah,
you are audible properly, sir.
yeah. Okay. So even if we have done a very good, excellent research work, uh, there are some guidelines are there, rules of the various institute that we cannot award a PhD degree without publishing a research paper. That means good work is there, excellent work should be there, but along with that, a publication a research paper is required. Then if you ask the same question to the faculty member, so if you're a faculty member and we ask faculty member, you can do the research, but don't publish a paper. But again, what happened? Then that particular faculty member cannot get, say, promotion, or there is no academic growth. So for a faculty member also, research paper is essential for academic growth and professional development. But the question has come, we are giving so much of time, so much of energy, so much of money is involved of the various of the institutes. So is research is only for obtaining a PhD degree and all or academic promotion. This can we do this PhD degree or that or this one uh, research or publish the paper only for these two purposes? Or then, but my understanding of research is that using fundamental knowledge solve the real life problems for the benefit of the society. Means whatever research is there, we have to see how can this problem or any problem is there, we can solve by our fundamental knowledge. The second thing is that using the fundamental knowledge, can we create a new knowledge that will benefit to the society? That means one is that whatever fundamental knowledge is there, we can apply to some real life problem. Second thing is that using the fundamental, we create some new theory, new knowledge. Can we benefit to the society? Then third, our research should benefit the students for placement, benefit to the government organization, various industries, and also directly help society through some innovations. That means that whatever research should be there, it should be applied and connected to the society. Then whom do we call a researcher? Means can we call a teacher as a researcher? Is it possible that anyone can discuss with me? Dr. Arvind? Dr. Arvind? Hello, Dr. Arvind? Dr. Arvind, am I audible?
Yes, sir, you are audible, sir.
Okay, any participant would like to speak with me? Any participant? Anyone? Hello?
हाँ
My
हाँ सर.
question is that
Yes sir.
whom do, yeah, somebody can speak. Whom do we call researcher? Here I have written researcher is a person who identifies meaningful problems, systematically searches for answers, and contribute to new knowledge or solutions. So, any UG student can be called researcher? Can an MTech student be called as a researcher? PhD students can be called as researchers. So, all the people involved in this academies can be called researchers only? Or there are some other person that we also call as a researcher? No, Dr. Arvind? Huh? Dr.
Sir.
Arvind?
हाँ sir.
You
I can.
can also discuss. You can also discuss. To whom we call
Okay.
researchers? To who we call
Yes sir.
researchers? Uh, Researchers means who can search for some answers, contribute to new knowledge for solutions. So definitely we are the teachers, students. We are doing this one. We are the only researchers. Or anyone can speak with me.
Yes, audience, if you are like sir is asking if you know the answers, or you may involve with sir.
Yeah. Hello.
हाँ sir, you may continue sir.
Okay.
Yeah. Yes sir, you may continue.
Okay. Anyone?
Yes, anyone till now, anyone?
To whom we call a researcher. I have told this is the way of research, that is searches for answer, contribute. So can we are the only the academician we call as a researcher? Okay. Anyway, I will continue.
Everyone
In
is
my
scared.
huh?
Everyone is
Anyway.
scared, na? So
Okay,
that's why.
okay, no problem, no problem. I will speak. So in my view, uh, research is not okay. Dr. Arvind, you can also speak sometimes
Okay, sir.
if you want to add something. Yeah. So in my
Okay.
view, research is not confined to laboratories, universities, research paper or academic degree. A researcher is someone who observes a problem, think deeply about it, searches systematically for a better solution, and applies that solution for the benefit of the student, society, institution, industry, or humanity. That is general definition. So according to my view, can we call a teacher a researcher? Teacher means only teaching in the class. A teacher who's not doing any research, just like we're writing there, but a teaching in the class. In my view, we call a teacher is also called as a researcher, because a teacher who continuously exposed the better way of teaching, so it is also a research. Sometimes when we teach in the class, we see that we are giving some examples, but then we feel that okay, that example is not so better, so we can improve that example, or we give some addition of the example. Sometimes in a class we only explain theoretical portion. Then next time we feel that okay, no, we have to add some simulation. Or sometimes we feel that okay, we will do some experiment in the lab. Then we can show to the students. So that is also a part of research. So according to my view, a teacher is also called as a researcher. Then coming to the important thing, farmer. Farmer plays very important role in our country. And according to my view, farmer is also a one type of researcher. So farmer is not necessarily a professional academic researcher, but farmer can certainly think and work like a researcher. So how can we say like this? So the farmer observes which seed performs better. Then farmer will do the experiments of that various times. Then the farmers compare the various fertilizers, irrigation methods, studies the soil weather conditions, and again learn from the failure, adopt the method, that gives a better yield with fewer resources. That means farmer is also called as a researcher. So whatever people who are working here, not only academician, those who are working, doing something innovative for the benefit of the people, benefit of the society, all are called as a researcher. That is my definition or understanding of the researcher. So, Dr. Arvind, am I correct about my definition?
Yes, sir, correct, sir.
Is it correct? Na? Okay.
हाँ sir, yes sir.
Yeah, okay. Then, how to write a research paper? Then, to write the research paper. So today, somebody is saying you can write the research paper. Then the student or that researcher asks, sir, what to write? So we cannot write a research paper directly. So before that, we have to work because then and then we can write the research paper. So now we are just thinking from the academic point of view, we have to write some research paper. So before that, as I told, we have to do some work. So what is the thing? We have to identify the problem. We have to identify the problem. Then once the problem identified, what we are doing? We are seeing various research paper around that problem. Then we learn that papers. Sometimes we go for some simulation studies. And based on this, then what we are doing? We are finding some research gap, something which is not done by it, and we think, okay, we can do it. And based on these studies, then we think some fundamental, because when we do research, we have some fundamental base. So whatever new existing thing we will read, whatever fundamentals we have, based on this, we are proposing some new approaches, new methods, and then what happened? As a guide or a faculty members, we tell students, okay, you develop a new method. Then what you can do, you can try to compare with the existing approach, and the students are doing it and they're comparing it, and then the student feels that okay, now the new result is better than the existing results. Then we say that okay, it's fine. So that is done by two different ways, by simulation studies and hardware. Initially, definitely we are going for the simulation studies, and presently what happened, if you want to publish a paper in a very top journal, expectation is of hardware. So now when we go for all these things, once everything has been done, then we are going to write a research paper. And once we write the research paper, according to the suggestion of the supervisor, we will submit the paper. And before sending, supervisor will see all everything and they submit the paper. So now the thing is that when we submit the paper, so before that we write the paper, how to write the paper? What is the understanding of the write the paper? Somebody said you can make the paper uh, such that it should looks like that it's something no, highly novel. So you add more and more some complex mathematics and submit it. Is it the way to write the paper here, Dr. Arvind? Dr.
हाँ sir.
Arvind?
Yes
Yeah,
sir, yes sir,
my
yes sir.
discussion now in all this, that
Okay sir.
is it okay now? Fine understanding what I'm saying here. That
Yes sir,
if
yes
you
sir.
want to,
Yeah.
we identify the problem, study research gaps, everything, and
Okay.
there's something we have to write. Okay.
Okay sir.
So what is the why I think that what is the purpose of this writing the research paper? So my thinking is that when we write the research paper, that should be understandable by the a layman or even a researcher who just started the research. If we understand this paper, then that paper, even though sometimes simple, has a value. Because you know that when you write a set paper in such a simple manner, which is easy to understand, then that paper is referred by the young researchers, scientists, and based on this, they start working. And again, there is a connection of your work with that work. But if you write a paper very highly complex, with top hardware and everything, what will happen? Definitely, can be published. Paper will publish. But whatever, what is the utility of this? That is remain in a in the literature, and every day so many papers are coming, and just like a bunch of files that will remain in the file. So ultimately what happen, ultimate aim is that whatever we do, it should be useful to the society, useful to the students. But if you do it like this complexity of this, then what will happen, that it is of no use. One of the example I would like to tell you, in on robust control, one of the researcher has written paper, and in around 1978 time, on robust control. And the idea is so innovative, but written in such a complex manner. So from that year 1978 to 1984, around 6 years, nobody has understood that paper. Even though the novelty is good. So what about after that, some researcher has come, then they have elaborated it and research, then it has been progress. That means although a researcher has developed the algorithm, but not written in a proper way, so nobody has used. But another researcher has come, has understood this, taken a time, and then simplified it, and that is used by so many researchers, and so many papers has coming, so many PhDs have done on this. Therefore, the ultimate our aim is that when you write the paper such that any young researchers can understand, it should be simple to understand. Mathematics should be there. It should be properly clear. If you have something, if you have some space is less, then you have to refer properly, so that when any researcher can read that particular paper, it is easy for them uh, to read it, and ultimately that also improve your value also. According to my view is that if you publish the paper, and it is the referred by so many researchers around the globe, that has more value than a paper published very top journal, but nobody reading it, nobody's referring it, that has very less value. This is the my view about about how to write the paper, or how what is the way of presentation of the paper. Dr. Arvind, is it correct? My view is correct. Do you want to add
Yes, sir.
something?
Yeah. No,
Huh?
no, no. Yeah, it is
Is it
correct.
okay? Fine. Na? Okay.
Yes, sir.
Okay. Now coming to the research thinking, how to do the research thinking. So research thinking, just I discussed that something new things should be come out, results should be new, something, some new innovative ideas. So, but there's sometimes because nowadays we are doing some collaborative work. As a here, I'm a faculty members. When I am the students coming to me, we are guiding. So it's just like a collaborative work. So I would like to give one example that which is by which you can understand how I have progressed the research. During that time, 2019, I had completed my doctorate, and then immediately after, I have also the student came to me and he told me that, sir, I want to do research under your guidance. Definitely, after completion of your PhD and somebody student is coming, you feel very happy because your as I told earlier, your future progress and everything, your growth depend upon the students, and if you get a good student, it's always better. So that student, the research scholar, came to me and he told he want to do work. Then I was happy that time. Then I asked him that, okay, which domain you like to work, which is direction of your work. Then he told me, sir, I have done some initially some methodologies or so. I have done some work on the image processing. Now told me image processing. Suddenly I thought, I don't know image processing. Even I have not learned anything about this image processing. I was completely blank about this. Then he told me, sir, this is my area. Then what to do now? But as I told that, he's the first student, and he came to me. And but anyway, I thought image processing not. Then I simply told, you can search some other supervisors, you can talk to them. Then he told me, sir, I want to do PhD under your supervision only. Then Dr. Arvind, what to do now
Yes, sir.
then?
Yes.
Huh? What
Yes.
I
Yes,
should
sir.
done that time, because he's so interested in doing under this one.
Ji.
Then he told me that afterward he told, after taking some time, sir, I know your research area is control system. I can do research in control system. Then that time I was very happy with control system. Then I told him, you tomorrow you come to me, my office. Again we'll discuss. Then after that I went to my house. Just give take some thought process. Some thought process come to my mind. Now he told me that he want to do in control system, and he has done most of the work in image processing from the whatever he has spoken to me. Then I thought, if you want to do in the control system, so it is as good as, because you don't know anything, it's good that I have to do my just like a second PhD. And already you know how much time you have to utilize and everything you have to take care in PhD. So I thought it is not a good option for me to do the PhD in a control system, because student is not doing anything. So what is the solution there? And student is interested. I can just some, and again in other way also we thought, okay, he's the first student. So Dr. Arvind, uh, Dr. Arvind, what is
Yes,
the
sir. I
solution
think.
for this? Student is image processing. Our is control system. So
Uh,
how do this one? Then immediately myself I have done little bit some searching on this. Then I have found that as my area is control system, our base is mathematics. And I observe that the mathematics is useful in the mathematics is useful in control system. So I have found a little connection to this. And I have found that there can be possibility that we can connect a control theory to image processing applications. And then what we have done that time, that eigenvalues are there. So that the next day when he meet me, I have discussed about this point, and he also revealed the same thing, that for eigenvalues and something are there are connections, and I have told that the basis of or control system roots. So from that angle, we have started slowly, and initially what we can say, we have submitted the paper rejected, and because it is a new dimension, new direction, new thinking. And Dr. Arvind,
yes.
that student,
Yeah. Yes, sir.
that student had completed a PhD degree less than 3 years, in 2.5 years.
Oh.
Because the innovative ideas, thinking that is somebody who has not thought about this point. Image processing and control, nobody has thought during, although presently something are coming, but what I recall during that time, nobody has thought in that directions. So connection with that, initially people have rejected our work. 3, 4 people were rejected. But after that, continuously 3, 4 paper were accepted, and immediately he has got degree. And because he had done a PhD within less time, he has got a chance earlier, and presently at very good position in very top institute in India, international, in an international institute. So that is the way that in research thinking means that you have to see your fundamentals, you have to see what new area, new dimension, and say how we can do the connection. But ultimately, all thinking should have some basis of fundamentals. Because your fundamentals are perfect, correct, then you can do to any research. Even if your fundamentals are correct, you can open multiple areas. But if your fundamentals are not there, it is difficult to understand, difficult to do it. So that is what we can say. We can have a certain type of some research thinking. Now, I hope, Dr. Arvind, my point is clear to you and also research other student
Ah,
researchers. What I
yes,
have
sir.
told.
And I,
Yeah, yes.
yes, sir. I
Huh?
think and that candidate name is Swati, na sir?
No, 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 not Swati. This is
Acha.
Dr. Vilas Gaidan. He is in Dubai now. Vilas Gaidan.
Okay, okay, okay. Good, sir.
No,
Good.
no, no. Actually, that student was not from IIT Roorkee because earlier I was in SIT. That time
Okay,
he has been assigned and I came and then he used to come to Roorkee only. Means all PhD
okay,
I had taken care from the Roorkee. So that is the example of
okay.
that Vilas guy anyway. First PhD. Within
Ji,
2.5 years completed. So that way that
ji.
ideas, help in
Yes, sir.
materializing or doing something new by connection of two different domain. Is it okay, Dr. Arvind? Fine?
Ah,
Yes.
yes, sir. Yes, sir.
Yeah,
Okay.
okay, okay. Now coming to the second thing. If I am saying in your life, you are doing so many activities from morning to evening, and if you doing very excellent other than academics in your personal life, professional in the sense, our life with our friends, colleagues, I think whatever thinking or ideas which is coming there, that can be a connection with the research. As I told that everyone are researcher, even a farmer is researcher, teacher is researcher, even you can say cricketer, even a Tendulkar, you can say a very good example. He is also researcher because he know how to play, how to do square cut, how to do it, how to understand the philosophy of the bowler, how he ball like this. So many things are connected. So everyone is researcher. So when we talk about everyone is researcher, whatever we are doing our general life, if you think that way, you can also get the solution. You can get the solution in your research also. So, Dr. Arvind, do you agree with this that what I have statements are giving? Uh,
Yes, sir. I think everyone who is doing something
uh,
new, learning existing things, they are researchers, sir.
yeah, no, my point is not. My point is that whatever you are doing in general life, okay,
Yes, sir.
that general life thinking, okay, general life means we are doing some optimization, है ना? In life also like a
हाँ,
optimization, okay.
जी sir.
So that optimized theory, if you use in our research, that also gives some research in academics also. Just
हाँ,
now, I would like to give one example. Okay. And this is the one of one student, uh, with long back, was very sincere. And after the completion of class, he used to come to me and telling me that, sir, I have done like this, like this. So, so already discussion is there. So initially, I thought that he can be among the top three in the class. But after the mid-semester examination over, when result has come out, the result was not so good. Then, then I asked him, so because no, you are, I had told him that you are regularly discussing with me, doing everything. What is the problem with you? Then he told me, sir, uh, I doing this one, but I also like some other activities. I also like sports activities, sports. So whenever I get free time, you know, so that time I used to go to sports. So I like sports very well. Then Dr. Arvind, Dr. Arvind,
Yes, yes, sir.
what
Yes,
I
sir.
understood the
Yes, sir.
point. The student is there. It's good in the initially I thought, but what happened? The result has not come out well. But he's told that my thinking is different. My aim is different.
Yes, sir.
I like sports. Like more. Then what we should do as a teacher? Then I
जी
simply told, why you come for engineering? Huh? You should
हाँ
go for any academy, sports academy and everything. Then he told me, sir, there are some home challenges, parents and everything. So I have to manage both the things. So anyway,
yes
from whatever answer is given, that's also satisfactory. Life is not like that, no? Because there are so many other challenges at your home also. So
Yes.
I am doing it. Then the solution. Then I have. Then mid semester was over. Then I told that what you can do now. Presently, when will be your end semester examination? They need to sir around after 2 months. Then I simply told what you can do. Now for next 1 month. Okay, you give some 70%, 60 to 70% time approximately to your sports. But definitely, you have to give 30% time to your academics. 70-30 like this, I told. And just after 1 month, make the reverse of this. Just make reverse of this. Means initially, give more weightage to your uh, sports, less to
Sport.
academics. And then after when examination come nearer, then exactly reverse of it. Okay. And during that time, some people, students were doing research and they are also not getting results. Actually, I have given an idea to the students about this, but I thought afterwards, can can this type of things can be solved our research, control system research, and surprisingly, sometimes that concept I proposed and told to my students, and they have developed algorithm and got a very top publications. So you can see that I have thought for the student point of view, and then they have connected to the problem of the engineering research with the ideas. It's not a mathematics, it's the ideas. Because when you do research, first of all, important is the ideas. And that ideas, we have to convert it into mathematics. Mathematics convert it into simulation, and simulation has to convert it into hardware. That is a way of the research. So now I see how general life challenges, problems we can say general life thinking we can connect it to your research because in life we are doing all that we are doing all optimization because when you create to the family we and when you are working as a family members you are working different institutes you have to manage your family you have to manage your friend circle manage your teaching manage your research everything is there so ultimately if you see that if you only focus on the research focus on research not giving the time to the family members or friends that is not good things and if you only say giving time to the friends, families, not doing any work, that is not also good. Somewhere we have to do the optimization. So research is nothing but the optimization of everything. So if you think that way, you can get a good solution to your problem. Dr. Arvind, what I had told, is it fine or do you want to add? Is it okay what I had told?
Yeah, it is fine, sir. It is fine.
Okay. Good. Okay. So now, Dr. Arvind, there are students are there from which discipline?
Sir, actually, it is all discipline students are there, sir. Not only
Okay.
electrical. Can
Okay.
give example, sir. They will understand, sir. They are
They learn better. Okay.
most of
So
them are
now I will
faculty,
try
sir.
because yeah, because no, because as a control, na, I can give definitely control example. Na, I cannot give other examples. So anyway, from control
Yeah,
point of view, to layman way,
yes,
I can try to tell to them what is my view about this.
yes, sir.
So students, now my figure is visible. One block diagram is visible here.
Sir, it is visible. The closed loops control system is there, sir.
Okay. Yeah, 1 minute. Okay, so here you can see that 1 minute. I think this. Okay, so here you can see it is written 1 by s squared 2s plus 1. And here is a PID. So as electrical engineer, you ask, what is that things? So the electrical engineer control system, they say that it is a system, this is a controller. So now those who don't have control background or anything, so you can say this 1 by s squared plus 2s1 plus, it is the one patient. This is the model of a patient. And patient has some health problem, and that health problem can be solved by medicine. So PID is the medicine. So PID is the medicine for the human being. So now in the domain of electrical engineering, it is called system, it is called controller. So medicine is a controller. Our system, it can be electrical, mechanical, a human being. This is system. So what happened in our control system? We design a controller for different types of system. We are designing a controller for a motor. We are designing control for inverted pendulum. For every converters also. For everywhere we design a controller for system as per our requirement. Or in layman language, you can say that if you have any health problem, what happen? When the health problem is there, we go doctor. Let us say we have a blood pressure problem. We go doctor. Okay, doctor will that measure your blood pressure, and according to that, okay, he say that okay, your blood pressure is say 140. So according to this, doctor prescribes some mg medicine. So PID is basically medicine to our system. So now for this plant, 1 by s square plus 2s plus 1, I have designed a controller, and then I have applied a reference input of 1, just like a uh, we have a reference of say blood pressure of 120. So it, let us say 1 is 120, and after giving the medicine, the response is around 1 only. That means result is fine. Means whatever medicine is given by the doctor is fine. So you can see the input is 1, steady state is 1. Whatever requirement is there, that is been satisfied. So that is fantastic results. So then what happened? Then someone has designed different controller now. This is PID designed by one researcher, or this for same machine, one researcher had designed this PID, and another researcher had designed different PID, different controller. So you find that the result of this nature, you can see there is an oscillatory behavior. Here there is no oscillatory behavior. Here is a completely oscillatory behavior, and then reach to steady state. It is simply you can say that the blood pressure is there. Initially, we have easily we got exactly 1, but now we take different medicine. We assume that we take a different medicine. Initially, the oscillating fluctuating, and then come to the proper way. Then from that angle, what we want, whatever problem is there we have, it should be done immediately with immediate effect. That is our requirement. So now one one controller has given this result. You can see the result. You can see you can see the last first 1 is visible, 1 very steady state. And second
हाँ
figure, you know, in second figure, this like this. You can see oscillatory behavior. Anyway, uh, this pen is not working. Otherwise, I would have shown properly. But anyway, you can see that the result is not. So now, which is the good thing from the our electrical engineering point of view? Which result is good? Or in other words, because now our topic is research thinking, publication of the paper, all these things. And I had told you earlier that when you get a publication, when you have some good substantial good result in comparison to the existing results. So if we compare both these two, so which is good? Which is good result? Which is the publishable result?
sir, it will depends upon the requirements, sir. Like suppose if we are doing model order reduction, sir, and our original system is giving overshoot under them, like next. So we can propose model order reduction that will give same response which is having also overdammed and underdamped. So for that case, that figure will be correct, sir. For
Okay.
another, if we don't want undershoot, overshoot, then this figure, first figure is the correct one, sir. So it
Okay.
will
Yeah,
requirement,
you're
sir.
correct. So as per your requirement, okay.
Yes, sir.
But in general, if somebody is saying us that your result giving highly overshoot, will you accept it in general?
No,
Overshoot
no,
means, let us
no,
say,
sir, no.
I can give a very example of a robotic arm. Okay, we
Ji.
pick the object and place it, and when the oscillate, our arm is vibrating, or when you place the object, the vibration is there. Do you accept the vibration? No, we will not accept the vibration. There are
Yes,
some
sir.
common things which will not accept, just like we cannot accept various highly undershoot, overshoot. We want results so that it should reach to quickly steady state. In other words, when you go to the doctor will give the medicine. What we recommend is that we should be cure within a 1 or 2 days. But somebody is giving the medicine, not fluctuation in your blood pressure, taking 10 days, we will not accept. Okay, so what is our aim is that, Dr. Arvind, you also said correctly, but here
Yes,
my
sir.
point
Yeah,
is that, yeah, my point is that when you publish the paper, because now we are thinking from here our topic here, research thinking and publication of the paper, research thinking, how to write the paper. Is it okay? Correct, na? What I'm saying? Topic
yes,
is
sir.
there.
It is
So,
yeah, absolutely.
so for publication point of view, which will you which will you say will be better for publication point of view?
Which is not having undershoot, overshoot, sir.
Understood. So definitely everybody can, most of them will say that we go for first. So your paper will be accepted. Okay.
Yes,
So
sir.
you can say that, let us say, um, if any system is there, we have some overshoot of 90% overshoot, and somebody has 10% overshoot. Overshoot means extra oscillatory behavior. So definitely 10% will be accepted. So here there is no overshoot, and we'll say that this is better. And in MATLAB, and when we compare it, you can see this type of result is come out. So you can see that the oscillatory behavior is developed by one researcher, and this without overshoot is proposed by another researcher. So here you observe that most of the things are in favor of this result where there is no overshoot. But here the result by overshoot, undershoot, that is not more convincing. And you know that in practical life also, we have to do certain adjustment. Everything will not get as per 100% as per requirement. So we have to see that where your requirement is mostly satisfied. So here also we see that where our requirement is mostly satisfied, particularly as Dr. Ravi said is very correctly, because it depends upon what type of application we have. Somebody we can tolerate overshoot, we can undershoot. But in general, there is a thinking that we should avoid the overshoot. That is the thing with good risk. Right? So based on this, I can definitely say that if you develop in one method for this, and second is giving this one, paper is accepted. But what is the role of researcher? I have told you in the earlier slide. The researcher's role is that whatever theory we propose or we develop, it should have some connection with the real-time applications. And again, we are engineers. Or today, even mathematicians or physics or science people also doing their work in the applied domain. So for everywhere, presently, application is important. So can this result will be helpful in the application point of view? Or when we try to have the result in a real-time application, which is gives the better result, which is better. Dr. Arvind, my point is correct? No? My
Yes, sir.
point.
Yes, sir.
I am saying that this result is good from publication point of view, but when we try to connect this to uh, our practical point of view, where is
Yes,
the challenge comes? Where is the challenge?
to
So
transient response. Uh,
yeah,
yes, sir.
transient is there. Definitely no, transient is there. We will not accept. Researcher can, I mean, from publication point of view or whatever topic we have, research, publication, everything, write paper. That angle
Ji,
it is
sir.
okay now. Second is better. But what I'm saying that our research should be applied. Control should be applied. Should be connected to the real-time examples, real-time system. So that angle when I am seeing, I have some observation on this. What my observation that paper is published, but when we taking the result for the real time, I found that the result which is not good in research is more beneficial than the result which we have got. A good result in publication. Dr. Arvind, am I correct? I understood what I'm saying.
Uh,
Research is
yeah, no,
okay.
sir. Yeah.
Hello, Dr. Arvind, am I audible?
Sir, you are
Hello.
audible. And yeah, whatever you are saying, sir, it is absolutely right, sir.
Yeah. Okay. So where is the challenge to us? Okay. So you can see that what is the controller role? Controller is giving a control input, and definitely that in control input has some limit. When you go to the doctor and as the doctor will giving the some medicine to control your blood pressure, sugar, everything. And although even I don't have much knowledge about the medicine, but in layman we can say that if doctor has, for example, high power medicine, so it may possible that blood pressure, sugar, which instead of going up, it can come down. So that the appropriate control input should be there. And again, when doctor is giving to the medicine, he or she will also see the condition of the patient, which is the age of the patient, 20, 30, 80, 70. So according to it, the doctor has to take the decision. So here also in our engineering, we have to take appropriate decision as pointed out by Dr. Arvind. So for this special case, just case I had told, when I have checked the control input from the PID controller. So you can see here diagram. You can see after PID one line is showing to you. Dr. Arvind, is this audible? Can you see it? Is it visible?
Yes, sir, it is visible, sir.
From PID one line is coming, one line is showing, and the scope is
It
there.
is,
One
yes,
scope is
sir.
there. You can see
Control
one scope.
input, yeah, it is going to
Yeah,
control automatically.
yeah. So both the PIDs are there. PID one, PID two. One is giving the good result, one is not giving the result. But when we are seeing their control input, and you can see the control input. The control input which is good, you can see magnitude of 120. You can see 120, 120. Result which is good, no oscillation, no oscillating behavior. Control input of magnitude of 120, whereas you can see the control input provided by the result which is not good, around 15 only. Hello, is it visible?
Yes, yeah,
Okay,
both the
you can see
control
the
signal
difference in
are
the control
visible,
input.
sir.
Yeah, and you say the control input has to drive the actuator. Actuator finally drive the system or taken care of the system. So, for example, if you're using the motor as the actuator, you can see for certain type of application, you can see how much cost is involved in this case if you having a such type of control input. So cost is also plays a very important role. Cost, and again, if you go for a very moderate type of machines, drivers, or some actuators, that control input cannot be tolerated. They will damage our system. So now, according to here, for this specific example, although we didn't try hardware, but for general way, I am telling you that if you paper is published, original will come out. So when we go with the real-time application, you'll observe that the results may not may not be useful directly to the industrial point of view. Therefore, ultimately, what is the important thing is that whatever research you do, whatever publication, take a second angle. Okay, new paper is second angle. You see that whether it is that design is feasible or not, or it is feasible for which type of system is feasible. Because it may possible that for your for some design, you require more cost. Then you have to clearly specify. Okay, our design is there that is useful for this purpose. This design for this purpose. Okay, and our design should be not be such that it cannot be applied for any system. It should be somewhere applied. So that clarity or clarification should be given in the research paper so that because ultimately our aim is to have it applied and definitely there are limitations from academic point of view, there are limitations from the industrial point of view, but both of them will joined, then that can be good output. So when that industry people understand that the algorithm proposed by the author, it is specific for this range, this control input, this way, then before applying to the real time by industry people, then what happen? He will see that okay, that is has this limitation, this advantage, and then that type of research is definitely useful to the society, useful to the industry person. So this is about my view about this point. Dr. Arvind is correct now or anything
Sir, it is
missing?
correct. I think depending upon the physical limitation of the system,
Yeah.
uh, so there will be constant in the control signal also. Means any signal, suppose if system is capable of handling only 220 volts, so we cannot give to that system 415 volts, like 420 volts, we
Yes,
can't.
yes, correct. So in simulation we can do it, we can do anything. But real time there are challenges. Okay. So one have my aim is that through this workshop related to research, your research should your thinking because research thinking should be practical oriented. That is the my suggestion to all the researchers. So you can see that here. Here we can when we compare, you can see the comparison of the control input for the good result, and you can see that here control input of the good system or good system or the controller which giving the good result is not so better on the control point of view. So this is simulation I have done through MATLAB like this. So ultimately, the what outcome my outcome or suggestion to every researchers, research may be beneficial from the publication point of view, but not useful for but should be useful from the maybe beneficial from the publication point of view, but not useful for practical point of view. That should not be correct. It should be useful from the practical point of view. Good research should not end with the publication. It should also have potential to solve practical problems. So ultimately, the solution-oriented research is helpful to us. Again, the next point, important point, avoid unnecessary mathematical complexity. Focus simple, understandable, and practically implementable solution. So I think, Dr. Arvind, you agree with this statement, this mathematical
Yes, sir.
complexity.
And
Yeah.
yeah, I think government of India is also encouraging us
Uh,
to research practical points of view, which we
yes,
can do.
unnecessary, highly complex mathematics. Avoid complex
Yes,
mathematics.
sir.
If not understandable
Yes,
by
sir.
people, that is not of so use. Or any
Yes,
complexity
sir.
is there, research. Try to make it simple so that any layman can easily understand. All the research papers should be such that all the formulas, connected things should be given because sometimes it may be possible that your design requires some complexity. But presentation should be such a way that it should be understand to everyone. That is the aim of this statement. Again, one thing is that Dr. Arvind, okay, what I want, Arvind,
Yes, sir.
Arvind, what I'm saying, I am publishing one paper, okay. Then what you can do, you work on that paper, okay. Produce some new research, correct, okay. Am I have understood what I'm saying? One research,
Yes,
let
sir.
us say
I'm
I'm developing
getting.
in a work, you are developing it. Then what happened? Whatever you develop, I will myself also work on this. I can again develop it. And once again, second level I have developed, again you try it. In this way, our research should be continued. So our research should have a very healthy environment. And it should not like that I am the boss. So my research is fine. Even any young researcher has done it. And he has used my, say solution. Then I can also work on that solution, produce new result. So that this research should be continue. Because there should be no stoppage of research. Your research should not stop anywhere. Because if you research done, nobody has understood, stop anywhere, it will not continue. But what happen if somebody has taken this problem, do the research, that researchers give the acknowledgement to you, and then that further results that also come to you. And anyway, what will happen? You can have a good connectivity. So ultimately, what is the final conclusion? As we propose a new approach, other researchers may develop new methods based on it. We can they study their improvement, identify their limitation, modify our original approach again. In this way, research continues to evolve. Connection of the researchers. Is it okay now, Dr. Arvind? What I'm saying here, is it correct? What I'm saying?
Sir. Yes, sir.
There should be connection of the research. Okay. 1 minute. Now, as you told about model order relation techniques, just a bit, Dr. Arvind. I think
Yes, sir.
my
Yes, sir.
laptop, 1 minute, some charging. 1 minute, 1 minute.
Okay.
1 minute. Just a bit. Is it charging? I'm connecting.
Okay, sir.
Okay. Dr. Arvind,
Sir. Yeah.
visible, na? Okay.
Good, sir.
Okay, 1 minute. Something problem is there in battery.
Okay.
So, anyway, this model order relation is the area of a control system, and this area and this application is such that it is useful in all types of applications. So the ultimate aim of this model order relation is to have a lower order model to simplify the understanding of the system, to reduce the computational effort in simulation problem, to decrease the computational effort, and also to make the design of the controller numerically more efficient and to obtain simpler controller. So that is the about the model relation. I can simply say in general way, those who are not from the control system or electrical background, it is said that a big system is there. We have to reduce to very smaller size, and they are giving the same performance. That is called a model order relation. Because let us say this is my space and this is a big system. And then it is giving some result. Then what happens? I will simplify it, pick a small size, giving the same. So definitely it is useful to us. So this is one of the area, and here in Roorkee, I taught to many students about this model order relation. So now today I am the main aim of this telling this is that how the researchers have thought, thinking, because our topic is thinking, how the researcher has given a thought process on this area and how the research progresses. Hello, am I audible?
Sir. You are audible, sir.
Okay. So now the participants in this area of higher to lower, there is one scientist called Y. Shamesh. You can see the year 1974. he published a paper, stable reduced order model using paddy type of accumulation. And he has given method that a big model reduced to a smaller size. And prior to this one, some researchers had developed the approach, but complexity is very high. So why Samesh has told that this approach is very complex and my approach is very good. But that time researchers found that result is good, better than earlier, and fantastic one. But what happened in 1974? The Shamesh has produced some result. Then one researcher that is called V. Krishnamurti, in 1978, he published a research paper on a simple criteria in electrical engineering control system. There is called a Rouse criteria. And the ultimate aim that Rouse criteria is to check the stability of the stability, means whether stable or unstable. For example, whatever voltage is coming 220 volt, so it is around 220. If it is coming 415, 415 means that is unstable. So that is the main aim of the Rouse criteria. And what happened is Krishnamurti, what he has done, the method which is used for stability, use this method for reducing the model. So 74 the paper has come by one researcher, and 78 a simple, a very efficient approach has come based on the classical theory. Even uh, we are teaching to the UG class in this method. When I was a student, my teacher also taught me this house stability criteria. And when I was in my earlier organization, I had taught the same criteria. Presently also I am teaching this house criteria. That means it's a part of UG curriculum and very efficient and useful. And that criteria has developed around 1877 time, 1877. After 100 years, Krishnamurti used this criteria for reduced order model and giving the better result than 1974. And also he pointed out that the result by Shamesh, some models which are reduced but become unstable. Because when your original plant is stable, big model is stable, we reduce it. It should be also stable. But this Krishnamurti and also another researchers who taught, they identified that this method has this limitation. So now the method of Shamesh was very popular that time. And then 78, he has come Krishnamurti, and Krishnamurti is an Indian scientist, researcher. In 78, he was doing PhD from IISc Bangalore, and he has produced such a simplified result. And you can see that certain so simple thing has come out in research. What you can expect, Dr. Arvind? Today, some very
Yes,
simplified result has come out. What we can do? Whether we have to stop that area? Otherwise, because such a simple thing
um,
has come out. But what
yes,
happened? People what we are doing, or researchers, they are identifying the weakness. Just like in life, we identify some weakness. So research means we identify some weakness in the existing result. So this paper is coming in 1978. You can see where the year is there. Dr. Arvind, August, is it visible? 1978.
yes, sir, it is visible August
August
19.
19. So what happened after 1 year? Okay, I will not explain the criteria because you are from different background. But ultimate aim is that to tell you that how the researchers has done research and whatever their philosophy thinking. That is my main aim of teaching here. If you the lecture is for especially for control engineer, I would have explained. But presently, I am not explaining all this. You can just understand that a very simple method, just applying this simple criteria which we studied in UG, get the reduced order model. And that researcher Krishnamurti has shown this with an example. So this is a eighth model. This is a transfer function is one system. And for system, they have taken one numerator and denominator and then obtained the reduced order model. And these are some responses. So, and it is show that these results are better. And he identified some weakness in Shamesh. So such a beautiful result has given. But you know, research never stops because there are two things which I already always identified. Research never stops. Nothing is outdated. Sometimes we say that PID is outdated. Is it there? Hello, Dr. Arvind? Sometimes we say, na,
हाँ
we go for
हाँ सर
advanced. But do you
जी
find that still PID paper are coming? Okay.
जी
Even you are working on research model, still paper are coming.
हाँ सर ये सर
So nothing is outdated. And we don't know where we can have that conventional research will be useful. Or today the time has come that you can connect the conventional to the advanced. That will be the more better results. So you can see that this method is best. But this paper has come in 1978 August 1978, and after how many months? June 1979. After 10 months, no? August to
जी
June. After 10 months, one researcher has come, that is the A.S. Rao, and he commented on the paper by Rao criteria. And he said that result is not good for low frequency. Low frequency. Low frequency means, suppose when we are doing the work, initially we have some transient and then we switch to steady state. Just like when you start your vehicle, any motor or scooter, initially we have a initial some transient phenomenon, you can observe that. And after a certain time, your vehicle will move with some steady state speed. So what that ASO I observed that the result provided by Rao criteria is not useful for the steady state. So that means even though the method has been so good in research, but somebody has identified in June 1979. Then because something will come good, many people just thinking on that. After June, you can see the paper. It is visible, Dr. Arvind, June 1979, clear na? Moderation, comments on this. Hello?
हाँ सर it is visible comments on model
Visible.
yes sir
Yeah. Then come after June 1979, after how many months? June, August, no, June, July. After 1 month, no? June 1979, paper has come. This
yes
is August 1970, just after 1 and 2 months. They have also identified problem in the route criteria. Because let us say it is just like I have developed my method and new method, and Dr. Arvind has identified some problem, and his friend has also identified problem. Another has identified. So what happened? My method. What happened to me? You know, everybody identified weakness in my approach. So similarly happened in 1979 that Vimal Singh has come out, and in this paper he said that a different models we get same reduced order model. Normally what happen? We have one big model, we get one reduced order model. Another model, higher order model, we get another reduced order model. But he identified that method is good, but for some many cases there are multiple models giving the same reduced order model. So, Dr. Arvind, you can see that the Shamesh has done work in 1974. Yeah.
yeah
Then this Vimal Singh has come out. So now, what is the final conclusion at this time in the research in horizontal modeling? Just imagine that we were at 1979 because there are two dominant methods. One is PADE, other is called Routh. PADE has some problem of the stability. Routh has some problem of such type of problems. That means now what advantage to the new researchers? During that time, what are the advantage to the new researcher? Now the advantage of research that now this research area is now open to everyone now because everybody has identified some problem challenges. And in addition to this, after August, you can see this two different plant. You can see GS, two different plants. and we can get the same reduced order model. You can see this point. This here s cube, s square, 3s plus 2, s cube, 4s square, 2s. So you can see here 3s and 5s, two different system. And when we see the model, for two different system, you can get the same model. So this is a very critical issue. And then, during that time, another research has come that is called Jain Pal. Okay. So now, if you want to do research, two best approaches are there, but both the approaches have some limitation. An area is open for you to research. How you think in that direction? How you think? Dr. Arvind, my point is clear to the audience. What I'm saying, two
Yes,
biggest,
sir.
biggest things, biggest approaches, both have some drawbacks. Now the area of research is open to everyone now. Is it correct? Issues are there. How we do the research thinking now? One method, good point, one negative point. Another method, one good point and negative point. So, and you want to do something new. Suppose if you want to buy some air conditioner at home, what we are doing? We go into the some market. We see the different ACs, air conditioners. Then the air conditioner, definitely that people there, they see that it has so much of cooling, so much of efficiency, so much of everything are telling. Then we go for another company that telling something other way. Then what we are doing? We are saying that okay, this machine has this problem, this machine this problem. So we are saying that any other AC, we solve the problem of both. So what happened during that time? In that time, Jain Pal in April 1979, he has come and he identified that he that there is some problem in one method that is called Paddy method has some problem, Routh has some problem, and he combined the weakness of this or taken the advantage of both and produced the result and published in the journal Electronics Letter. So, Dr. Arvind,
Yes, sir.
what are there? What I do? We have to see the positivity of the different approaches, combine the positivity and produce some good result. So same thing has been done by Jain Pal in his research paper. And luckily, he was the faculty of IIT Roorkee and then he joined to IIT Kharagpur. And he is a very well-renowned researcher in the domain of model order relationship, Jain Pal. So I'm not, as I told you, I'm not going to explain these methods. Just I'm bringing some ideas that how the people have done the research. Now, the Jain Pal has come, then this Rao has come, then another researcher is what is that
Lamba.
researcher name? No, Halamba and then this. No, their researcher name is Vimal Singh, you know, Vimal Singh.
Yes,
So
sir.
many
Vimal
researchers. And
Singh.
who is the starting point? Who has done a starting
Lamba.
method? Shamesh, you know.
Samesh,
Shamesh
yes,
is the
sir.
person or a researcher who has started some basic innovation in the methodology, just like a Pade. Then he has come out again. When he's come out in 1980, in April 1980. So you can see the paper in middle of this Jain Paul has come, but actually connection with this is with this August 1979. After August 1979, we can say that the April 1980, after 7 to 8 months, why Shamesh has come. He said that see a language failure of the Rouse method of reduction. Miss Shamesh know that he has some problem, but what happened? He has identified the problem in the route, failure of the route. He what is failure? Means who is the best?
Samesh.
Shamesh. Failure of the route method of reduction, automatic control. And he said that in the paper, you can see April 80, attribute transaction automatic control. Rouse Harvey's method is shown to have a serious disadvantage in that method, that is reduced order may approximate the non-dominant pole of the system and hence lead to erroneous approximation. Numerical example is compared to Routh method of the Paddy approach method, and he has shown with this method, and he has taken this example and this numerical example, and he has applied the Routh criteria, got some result, and you can see that one original system, although for other non-electrical may not understand, but I can simply say that two methods they have same response, or they have to go in same direction. You can see that one model is like moving like this. You can see, other is at the very bottom. You can say they should be matching. So there is no matching, and here show it. And he said that if you do like this something way, or he has proved that by uh, comparing poles and zeros, and he said that the result is matching. So you can see that dotted line and one still line. So both responses are exactly matching. So according to this Shamesh, what happened? This is we can say a complete failure of the Raoult criteria, according to this one. And he proved, and that Shamesh proved that now presently, although I have some limitation, but my method is somewhat good than the existing one. So Samesh, which written paper in 1974 on that domain, 1980 has come. So what should be the future of this area now? What we can do, Dr. Arvind? Just imagine we were that time, 1980s time. Hello.
Yes, sir. Yes, sir.
Okay, clear na? What I'm saying the point.
But
So yeah, but the research never stop. Thinking never stop. Thinking never stop. And what happened? Shamesh come in which year? January
1974 and
Jan
19.
1981, January 19.
Mhm.
And just after 6 months, case Jung has come. Sorry. This is done is Shamesh. Sorry. I missed this point. The Shamesh, he has said there are a lot of problem in the this paddy. He has proposed a new method in January 1981, a truncation method of reduction and viable alternative. Means what happened 1974 to 1980? This problem of the route, problem of the paddy, and some other challenges. Shamesh has and he has identified the problem of the route in 1980. You can say April 1980, and again he's come with publication January 1981, and he said that truncation method of reduction is viable. And control engineer, they might know that truncation method. This method does not require any calculation. Even there is no need for addition and subtraction also. I think Dr. Arvind knows it because he's doing good research in model ordination. Dr. Arvind? Yeah.
Yes, sir. Yes, sir. Yes. Thank
There
you,
is
sir.
no need for any calculation. Nothing is there. Just a truncating the values. For example, if you say this, say here, this is 23432, 1.21.432s plus 14.96 s square, 253502742s, 135727 s square, 113225 s cube. Here this order is fourth order. S4 is fourth. If you want to reduce to a lower order, let us say third order, what we can do, just discard the S4 term. We can get the reduced order model. No calculation, no criteria, nothing is there. You can see that what a change has, what a method proposed by Shamesh in 19, which year?
1981, I think.
On January 1981. And
Yes.
prior to January 81, when he has published paper? January, April 80. So what Shamesh has done, first of all, identify the problem in the route. He said that route is not good, even though my method is not so good, but route has completely failure. He provided in April 1980, and then he has come in 1981, January 81. He said truncation a viable alternative, published in Electronics Letter Journal 81. And so no calculation, the thing is there. So you can imagine that if one approach has published, no calculation, nothing is there. I think there is nothing to do it in the future. Because such a simple method had been developed by the Shamesh. Definitely, Shamesh should have been so much happy during that time that he has produced such a good result. But unfortunately, the happiness has not been extended for a longer time. Just after 6 months, in May 1981, K.S. Jung has come. He said that the method proposed by Shamesh on truncation method, which is so simple, so efficient, may not be so helpful if the order of the system is greater than 3. For those who are not electrical background, means that if the system is of lower order, small system, used to a smaller, it is applicable. But the system is very big one, that method cannot be applicable. And if from control point of view, the control engineer, if the order of the system is 3 or 4, it is okay, or even 3 is okay. For order is n equal to 4, n greater than 4, instability of the reduced order model may indeed occur. And what happened, he proved with an example. You can see the paper. Electron etc. Stability of board by truncation. K.S. Jung is the author. And he said that, let us say a plant is 1000, 10,000 S5, 10,000 S4, 240 S cube, 200 S square, 7 by 5S, 9 by 10. And he truncating means only these values. And original system has roots. You say all negative. All negative is stable. So original plant is stable. Truncating means this 1003 was 1 lakh, around 1 lakh. SH to 5 has to remove, keeping only this 10,000 S4 terms, and when find out roots of the equation, two poles are positive sign, system is unstable. So those who are not from electrical background control, stability of the system is roots should be roots. You know it, everybody. When we calculate the roots are positive. Some roots are positive means system is unstable. If all roots are negative, if all roots are negative means your system is stable. So you can see that this system has unstable. So original model is stable, results are stable. How can we accept the result? And ultimately, he also given his thought process. Somehow he said that for well-damped system, release order model obtained by truncating higher order trans of its Cauchy-Polar are stable. For oscillating system, be always the case. So he has given with all mathematics, all proofs that this is the observation. So, uh, Dr. Arvind, Dr. Arvind,
Sir, yes, sir.
you can see he has done this one. And Shamesh starting from 1974, he has come in 1980, 81, and then come the this yes, Jung has come. Really, he was not aware of the scientist. What Shamesh can do now? What option is available to Shamesh? Because his this pad has that problem he has observed. The truncation has some problem identified by K.S. Jung. Now, what way uh, that what is Shamesh has thought about it? Is it okay now, Arvind? Is it clear now?
Sir,
The
okay. Yes,
researchers understanding about this problem, thinking of the research.
yes, sir. Yes, sir.
What option available to us or available to Shamesh? Because Shamesh is the pioneer in that domain. Because now he. So what option is available to Shamesh? One option is that again identify some problem in the case Jung approach. Okay. And other option is that produce some new method, new approach. Is it okay, Arvind? This is the option thinking of the researcher. How researcher will
Yes,
think
sir.
in that
Now,
way also.
um,
Huh?
yeah, yes, sir. He got some is like got idea what is the drawbacks and what is the advantages. So
No,
now,
no, that is okay. But
yes.
Shamesh method has been completely outdated, na? Means say that not useful, na? KSU
Yeah,
has said
because
that.
yes,
Huh?
sir.
Means for
Yeah,
more than third order not applicable. Okay.
yes.
Then Shamesh has to prove that, na? He has some more new method because anyway, when we are doing research, okay, we are going for some upgradation, hmm, upgradation of the new work. So where is the upgradation possible? So either, as I told correctly, that we have to think over it. And second option is that produce new method. Do you feel that is there a third option, Dr. Arvind? Or any researcher can also tell if they are
Yeah,
watching this.
he may change his area, sir. Like he may change from model order reduction to some other
Okay.
area.
So that means you say that we have to change the area. But sometimes it is difficult to change area also. Okay. But in the
Yes,
same
sir.
area, he wants to do something. What is the option? What generally we think?
He
Generally,
may
what
go
we
for
think?
application point of view, practical point of view.
No, no. He has done a different way, different thinking process he has applied. He is not going for application. He has not developed new method. Afterwards, always afterward he would have done it, but just after it. Just I was thinking, what his course of action, his action, because definitely he has to take the act of action, no? Okay, some action he has to take it. So one action, as you suggested, that you have to change the area. Second option is what you told. He has to go with the application. What third option I had told? That he has to identify some problem in the Jung's method or a new method, means that is a new area. Is there any other option is available other than that? Is there any other option in the research? Is it interesting, no, Dr. Arvind? Now the thinking
Yes,
is
sir.
there.
It is interesting, and yeah, audience may also give their points. Like sir is asking, Samesh is now learn different types of drawbacks and limitations in his methods and other methods. So now what is his next step?
Next action. Both the initial method he has developed is very good, but identifies some problems. Then he has given very simplified method. So now, Dr. Arvind, surprisingly, he has done,
Yes, sir.
so this paper is coming. So we started just a bit. So Shamesh started in which year? January 1881. Then Jung come in May 1981. And Dr. Arvind, he has not stopped for more than 1 year. He came in the same year in December 1981.
Yeah.
Start to end. Huh?
Yes, sir.
He has not waited for another 1 year or 2 years. He
Ji.
came in December 81. And what known to the researcher during that time? He said that all the existing method after say around 1974, they are not a so good appropriate method. From application point of view, the method which is good, that is a paradigm method which has developed in 1974, is the best option during that time in comparison to all the methods which are the best during that time. So he has shown, you can see viability of method power table. You can say December 80, is it visible? December 81. Dr. Arvind, you can see December 81.
Yes, sir. It is
So what
visible,
he
sir.
say that the various methods for generating a stable disorder models are shown to have a serious disadvantage in that resorter model may approximate non-domain polynomial of the system and hence to lead erroneous approximation. Example is given to compare these methods with standard Paddy approximation. You can see, Dr. Arvind, what is the standard Paddy for which this disadvantage does not exist. The 74 is said good. So a problem now 80 said that my method is good, Paddy is good. And definitely, yes, put me some examples. You can say, is it visible now? Visible? Dr. Arvind, visible? Screen visible?
Yes, sir. Yes, sir.
So you can see original model like this. Original Routh is that is a stability equation method. That is also very popular at that time. So two dominant methods, Paddy, Routh and stability equation method, and he compared, and you can see the result. So you can see steady state around 1, and the reduced order model, you can see the response is matching. This line you can see reduced order Paddy word. Is it visible? Na? Around 1, there are two graphs are showing here. And original system, and bottom side you can see reduced order system by Routh, stability reduced system stability equation method. You can see here shown the vast difference in the performance by his method, Paddy, and other method. Is it clearly visible, na, Dr. Ravi? Comparison studies.
Yes, sir. It is clearly visible, sir. Coming.
Visible that Routh and stability are not far to this. It is as good as, let us say, one student has got 95 marks, 95 or 9.5 CGPA. Other two students has got only 7 CGPA and 6 CGPA. Like that difference has come out. Is it okay? Na? Example, one student has got
Yes, sir.
9 CGPA, remaining two students has got 7 and 6.5 CGPA. So definitely we can say the best of best is that student who has got 9.5 CGPA. So here we can see the Paddy has got best result. So he again come out this one. And you can see that. Do you see any challenge here? Problem? Suppose now we have to now as a researcher we have to tackle this problem ourselves because he proved with the example. Do you see any challenge his problem? As a researcher, as a practitioner, we have to see this result because we have to take this leaders for application point of view if you want to take it. And Paddy has shown a very good result. And the popular methods, Routh and SBL, stability equation method, they are not doing the bridge results. And I want to take this Paddy result for my application. Shall I take it, or I have to do another other observation, or I have to go with some other testing? Hello, Dr. Arvind. Uh, have you
Yes,
understood
yes,
my
sir.
observation now?
Yes, yes, sir.
Whether I have to use Paddy, can I use my Paddy for my application? Now we have to think how we think now as an engineer now. Now we thinking come as an engineer, and our we have this type of setup implementation also. We have all these three methodologies available to us. We have to use out of three for our application. So here we can say directly the Paddy or the way of performance of the Paddy is far better. It's as good as I have to select someone for my project. I have got three students. One is 9.5, 7, and 6.5. And Dr. Arvind, which to be selected? I know. Definitely, we thinking about 9.5. But again, we have to see is there any other aspect of that 9.5 CGPA? Because I have to use for the project. We have to see that whether because that way I also said okay, CGP 9.5, whether he's stable, mentally stable or not, whether he follow our advice or not. whether he'll do work honestly or while doing other work, he'll do other work or not. So all these aspects are also important when we think like this. Am I correct, Dr. Arvind? My observation
Yes, sir, correct.
is correct, na? So now this is the observation for the general life. Now we connect to the this problem or as an engineering problem of model order reduction. So which thing is missing here? So when I observe that, you can see in our engineering application that time is also very factor. So when the result proved by the PADE, you can see the time limit. Time is what is mentioned here. Is it visible, Dr. Arvind? Time is it visible here from that side, your side? What time is mentioned
Yes,
here?
sir. It is visible, sir.
4 seconds, na? 4 seconds.
Sir, both
Time
the
4 seconds is mentioned, na? So that means here it is a very small time, 4 seconds. Then when I have done myself and we have extended the time, and when I have changed time to 140 seconds, you can see the pattern has shown the result for 4 seconds, and we have shown the now I have changed to 140 seconds, and you can see the comparative studies now. Now when we have changed the time, that from the comparative studies, the student will got 9.5 CGPA, but the remaining student they are not 6.5 CGPA, they are around 9 CGPA or around 8.8 or 8.7 CGPA. They are not so far away, no drastic difference. They are nearer to the 9 point CGPA, 5.5 CGPA. So we cannot say that uh, directly that PADE is the best. PADE can be somehow best. Two results are nearer to this one, and other also the aspect to be we have to recover. Okay, so that way, as a research thinking, research has to think in a different angles. Hello,
yes, sir.
1 minute. The
Yes,
researchers has to think in a different angles, different aspects, practical application, general life way. You think in all these different domain directions, you can be a very good researcher. And to become a good researcher, what is the most important thing? First of all, you should be very good teacher. Generally, if you become a good teacher, you can become a good researcher. So you try to improve your teaching skill, teaching aptitude, teaching skill, and thinking that way, automatically the next step of teaching is the research. You can do very good research. So now the time is also very important for us. So I am really thankful, Dr. Arvind. You have interacted with me, given your suggestion, and I know that you and your team are also doing very good research in your domain. And thank you for inviting me in this particular talk. And main thankful to this all the participants who have been there from last 2 hours with me. And anyway, if any your suggestion, that also welcome. But right now, thank you for everyone for attending my lecture. Thank you.
thank you so much, sir. And participants, if you want to ask any queries from sir, so sir is available here. If you have queries, please ask. So I think there is no queries, sir. So I'm concluding the session,
Okay,
sir.
okay.
So
Okay,
thank
thank
you
you.
very
Thank
much,
you.
sir, for delivering such a enlightening and engaging lecture. Your valuable insights, experiences, and thoughtful discussions have greatly enriched our understanding of the topic. I am confident that all participants have benefited immensely from your expert guidance. We sincerely appreciate the time and effort you have devoted to this session despite of your busy schedule, sir. On behalf of organizing committee and all the participants, I express our heartfelt gratitude to you, sir. Once again, thank you
Thank you.
very much. We wish you good
Thank you
health.
and all the best to our participant and you and your team also doing very good work.
Ji,
Benefit of
thank
the
you.
student and definitely benefit of the society. Good work.
Yes,
Thank you.
thank you, sir. Thank
Okay,
you so much.
thank you.
Have a good
Okay. So I am leaving.